Hi guys, welcome to Squaring of a Number, which is a speed maths topic presented by competitionmentor.com. So what is squaring of a number and why it is used? Basically in exam like banking, sometimes in your calculations, you need to square a number. Most probably for banking aspirants, these are very common as they get directly squaring a number and then there is some simplification method. So knowing this method is important because then you save time. Obviously it is a speed maths and it helps you cutting down your time and not wasting in doing rigid or whatever calculative maths, right? So we'll begin our discussion. Now first one is square of a number ending with 5, right? So what is square of a number ending with 5? So basically generally 25 square, 35 square, something which unit digit is 5. That's simple to understand, right? So now what is the funda actually? The quick way to square numbers that end is 5 is using formula. Like by one more than the one before, right? This is what it's called and we'll get it what it means. See 75 ka square is discussed here, right? 75 square is 5625. So 75 means 75 into 75. Now this means you can consider them into two parts, like this is 75, this is 75. And as per our prerequisite, this number ends with 5. Both of them ends with 5, right? That's the meaning of 75 square. So what is the basic funda will be, you have to go to 7 and add 1 and multiply. So when you add 1 with 7, you get 8, like you do plus 1. So 7 into 8 is 56. That is your one part. And your last will always be 25, that is 5 into 5, right? So this is the smallest trick you should know which helps in getting a speed math logic for numbers ending with 5. I hope it's clear. Whatever number you have, for example, if you consider 35 square, right? So 35 into 35. So 3 plus 1 is 4. So 3 into 4, that is 12. And actually 5 into 5 is 25. So 35 square is done. So as you can see, there is two examples, or I have placed in front of your screen to make you understand this logic in a very simple way. So if you have any doubt with this one, please post in the comment section. Thank you. Now the second concept is first figures are the same and the last figures add up to 10. So what do you mean by that? Just say this example, 32 is there into 38. This is pretty same kind of example like the previous one. If you understand now, you will get it. See, the last two will add up to 10 and these first two are the same. For this kind of condition, what you will do? You will again the same way, 3 plus 1, that is 4, and you multiply 4 into 3, that is 12, and you multiply these two as you did in 5 into 5 last example, 16. See how simple it becomes when the first digit is same, the last two adds up to 10. And if you correlate this with the previous example, it is kind of the same thing. If you do 25 square, the 25 into 25 last two adds with and it makes a 10, and 2 and 2 remains the same, which is the same logic which I have used here. I hope this logic is clear. Now in this one, we will see squares of a number from 26 to 75. The only prerequisite you should know, that you should know the squares up to 25. That is at least mandatory when you are knowing squares. Wherever you will go, at least you need to memorize. You should know till 25 ka square. That is very important. So now we'll discuss in this case squares from 25, 26 to 75. Now see, there are a lot of methods in this. There are a lot of methods. But I'll discuss the one which is applicable to all and the easiest one. And it depends person to person to say which is the easiest. But I can say upfrontly that this one is really easy. So now let's see what happens. Now see, for a number close to 50. For example, numbers from 30 to 75. but this is actually applicable to 26 to 75. This is, do not get confused that I have not written from 26 to 75. You will, by the end of this slide, you will understand that part. So here we find the surplus or deficit of the number from 50, denoted by x in the following expression, and then use the following to find the square. It means we do this. Now what we are actually trying to find is, let's consider this example and what we meant with that. Just remember this expression, and you don't need to even remember once you get the logic. The answer is arrived as in two parts separated by this one, right, in the above expression, which is this. The right hand part of the answer has to be exactly 2 digit. Understand, this is very important. This is 2 digit. Any extra digit has to be carried or forwarded to the left hand part, and the right hand part is a single digit. If the right hand part is a single digit, it has to be superseded, forwarded to the left hand part, and the right hand part is a single digit. It has to be superseded with 0. Now what is this? So let me begin with a very simple example and make you understand what entirely all this expression is and what it's going. Once you are done, it's very easy. So 51 square. So how much is it in surplus or deficit with 51, right? So basically the reference will be on your two parts. This part will be 25, say, reference. See here, 25 plus x. So 25 plus 1 is 26. Now what do you do? How much great is it, right? How much more or deficit is it? You do the square. So it was 1 more, that x was 1. So 1 ka square is 1, right? But it has to be 2 digit. Last, this part has to be 2. So it takes 0 form. This much is very clear, right? And as it said, if the extra digit is there, it has to be carried. And that is mentioned in this part. Understand the reference from 50 and how much more or less the x addition or subtraction will take place on 25. Now let's take one more example and we'll discuss. Within 2-3 examples you will be fully clear with the logic. So I'll take this example also. 59 square. So how much is it greater than 59? It is actually 9. Sorry, I meant 50. So 9, right? So 2 parts, again consider as 2 parts. So it is greater than 50 by 9. So our x in your mind should be 9. Now you have to add this surplus from 25 that we have done here. 25 plus 9, that is 34, right? And what is the x? That is 9. So 9 ka square is 81. See how simple it is to do the square. Now let's discuss some case where there is deficit. So otherwise I have not placed any deficit in this one. So I'll do one example and try to finish it off. Now try to solve this one. 39 square. Try it, pause the screen, try it yourself with the logic which you have understood. So 39 square, the reference point should be 50. How much less it is from 39 from 50? That is 11 less, right? 40 and then 1 less. So if it is 11, so x is 11. So you will go 11 minus 25. So 11 minus 25 is 14, right? So the last two will be 11 square, that is 121. As you know, the last two should be 2 digit, so 1 should be carried. So answer should be 1521. So I hope this you got this logic. With the deficit also, the concept is almost the same. Just you have to go down or more. The reference point should be 50, but the action which you are going to do is on 25, and then the last two will remain the same. If there is any surplus, the 3 digit, it will get carried here, and that's all the logic you needed to know for this question. So you can see how easy it becomes to square. Once you don't have to remember any expression and all. Once you get the concept, that's all done. right? Now this is numbers close to 100. In most of the exam you will encounter numbers from 1 to 125, 135, where you will need the reference of speed maths. So again, as like the previous example, the expression will be this one: 100 plus x ka whole square equals to 100 plus 2x. So it simply means, can you identify the difference? In the 51, where the number were closer to 75 to that part, the old part, 75 to 26, the reference was 50 here, right? And here you can see the reference is 100. And here it was just x. So the reference here is 2x. So that's all you need. For example, 103 ka whole square. What do you see? There is 3 greater. The reference will be 100 only. Just in the 50 case only you are dealing with 25. But in this one, that's the only point you have to understand. In this one, the reference remains 100. But x is actually 3 as it's greater. Surplus is 3. So you will do 2x. That is 2 into 3. That is 6. And that's why the last part remains the same. The surplus, which is x ka square, you do, that is 9. So 9, and as it is 1, so you will do the 0, 9. That's what it's discussed here. So as you know, like, this expression is the main thing you have to keep in mind. You don't have to memorize after certain example if you follow speed maths, because it's not a one-day thing. You will get the logic clear with you. Now similarly in this one, numbers close to 200 for numbers from 175 to 230. Again, so there is slight mistake here. It's 200 and it should be here as 200. By mistake there is 100. So consider 100 plus, 200 plus x ka whole square equals to 200 plus 2x into 2 plus, that is this side, x square, right? So this is the expression. Again the logic will be similar if you follow this example. You can see 200 plus 3, the x is 3 more surplus, so you will do 2 into 3, but this is the 200 is the reference here, and into 2, and the last one it is 9, that's why 0, 9. So this is the answer. It is very easy. I think now it becomes self-explanatory with the previous examples which I have discussed before. Now numbers close to 300, for numbers from 275 to 330. So again the expression is this one, and it becomes really simple if you understand this expression from the previous example. So I will not elaborate here more. So as the rule again remains the same, and there is one example which is very self-explanatory with the reference of 300, the surplus of 3 into, say, the x into 2 and then into 3, and the last part as it is. You can try this with a lot of examples, put it in your mind, try to do it without pen and paper, and try to implement this in really daily life. Otherwise, when you encounter these in questions in exams, sometime in banking they ask you simplification questions with certain squares, right? Sometimes. So this is collectively important for everything. It's not that they are going to ask you directly, tell me the square of this one. But yes, in banking exam, simplification is there. They ask you almost, like, it's a huge weightage. So those people who has a speed maths logic in squares and all, that's important. Sometimes also in calculation, when you're calculating something, sometimes you need these logic also. So it's not important to understand how to do it or why to do it, why to understand, but sometime collectively you will require them in your exams. So and if you learn this video now and you just forget it, write it down somewhere, it will not be beneficial for you. You need to practice speed maths every day. Just pick up some number, try to collectively recall these things in every day, and then you will be master of that topic, because it's the concept that is hidden in the speed maths. There is no rocket science involved there. So thank you for watching this video. If you like our the video, please subscribe or like in the YouTube channel, and you can like us on Facebook or follow us on Twitter. And if you like generally whatever I do on my website, if you like to donate something, there is a page on your right hand side of, if you're watching from the website page, supportcompetitionmentor.com, and you can donate anything from 100 to any amount which you like. but still we are free. We'll always make perfect videos, no demo videos, and that will involve and help every candidate to crack exams, whatever they are writing for. So mostly we are in CAD, banking, SSC, but still this will be helpful for a lot of people trying to understand logic for their own exams. So thank you for watching again, and if you have any doubt, please post in the comment section. I will reply within 24 hours, and thank you so much.